Hello everyone, I am Corbin Kumar and I will be discussing innovations in biology and technology, vaccines, today. This project bridges biology and technology by exploring the history of how vaccines developed over the centuries and how recent technological innovations like mRNA vaccines have revolutionized the manner in which we combat diseases. Let's explore the science, history, and impact of one of biology's most valuable resources. We're targeting vaccines because they exert one of the greatest impacts on global health. Smallpox and polio used to be deadly and widespread, but thanks to vaccines, they've been almost completely eradicated. Studying vaccines is a great example of applying biology to real-world health problems. And as new diseases emerge, technology will be playing an even greater role in solving them. So vaccine advances are both scientifically and socially important for today's world. Essentially, vaccines teach our immune system to recognize harmful invaders, like viruses or bacteria, before we get sick. They do this using weakened or killed pathogens, or even components like proteins or mRNA. In this way, the immune system is conditioned to respond quickly and effectively, building a memory so that when we get exposed to these pathogens later, our body can respond quickly and effectively. The origin of vaccines dates way back as early as 1976, when Edward Jenner developed the first smallpox vaccine using cowpox material. That was the start of immunology. Jonas Salk, later in the 1950s, came along and developed the polio vaccine, which cut polio cases across the globe drastically. More recently, once again, the pandemic of COVID-19 pushed science even further, which resulted in the creation of mRNA vaccines such as Pfizer and Moderna's in 2020. All of these are amazing landmarks in medical science. Vaccine development closely follows the scientific method. First, scientists ask themselves, can we use biology to stop this disease? Next, they hypothesize that exposing the body to a harmless version of the germ may create immunity. That's tried in clinical trials, which are conducted in multiple phases to check for safety and complete effectiveness. Data on immune responses are analyzed, and once everything is okay and safe, the vaccine is approved and finally released to the population. Vaccines activate our adaptive immune system, which is designed to remember threats. When we are vaccinated, our B cells and our T cells become activated. B cells produce antibodies, and T cells help kill the infected cells. Both cells work together, create memory, so our immune system can react much more rapidly if ever infected by the true pathogen. That is how long-term protection is created through vaccines. mRNA vaccines are a groundbreaking innovation in contemporary medicine. Rather than employing a portion of a real virus, they contain genetic codes, or so-called messenger RNA, that our cells can utilize to produce a harmless variant of the viral protein. This helps prepare our immune system to identify the actual virus without ever having been infected by the pathogen itself. The outcome is a robust immunity with much reduced risk. One of the greatest benefits of mRNA technology is that these vaccines can be developed very rapidly and economically. They need fewer parts and can be manufactured much more quickly than conventional vaccines. For example, COVID-19 mRNA vaccines were developed within a year, something that would have been impossible with conventional techniques. Vaccines are not abstract; they've changed the world. Smallpox has been completely eradicated, and measles and polio have been cut drastically way down in most nations. Vaccines prevent more deaths annually than anything, based on the WHO and CDC reports. Without vaccines, even more outbreaks would happen a lot more often and could be much more lethal. Vaccine misinformation is a public health crisis. Maybe the most pervasive myth is that vaccines can cause autism. a myth born and discredited in a 1990 study. The study was later retracted, and several large studies have confirmed that there is no correlation. But once the misinformation is out, it spreads fast, especially on the internet. That is why it's so important to know things like herd immunity. If the majority of the people in the population get vaccinated, it protects those people who cannot be vaccinated themselves, like infants or people with weakened immune systems. To protect public health, we need to look to science evidence, not rumor and viral disinformation. Peer-reviewed, credible evidence is our best chance to make sound decisions and protect our communities. Good science relies on peer-reviewed research, meaning that other experts have vetted the information. Large control groups and sample sizes reduce bias. Openness to seeing the science happen too. When people can see the science, they're way more likely to believe the outcome. That's particularly significant during pandemics when misinformation can spread rapidly. Vaccine innovation is the intersection of biology and technology. New technologies such as mRNA and AI are also accelerating the creation of vaccines and targeting them better. These technologies are saving lives, averting great epidemics, and vaccinating more individuals across the world. But there is still a lot to be done, particularly in being able to distribute vaccines to all nations. That is why research and investment matter. Here are the references I used for this presentation. All are from credible resources and scientific sources. Thank you.